Today we're going to learn to combine like terms. But before we do, we need to talk about what some of the words that we're going to be hearing mean. Most of these should be review. You have these in your notes packet, and you can fill them in as we go along. The first word that we need to talk about are terms. Terms are pieces of an expression that are separated by addition and subtraction symbols. So for instance, a term could be just a plain number, or it could be a letter, a variable, so it could be 7x. That is a term, just a single number or constant value of 6. That would also be a term. So when we look at an expression like this one, how many terms does this expression have? So we start counting, and each time we get to a plus or a minus sign, we count a new term. So this one would have 1, 2, 3, 4, 5 terms. So this would have, that expression has 5 terms. Our second vocabulary word are like terms. So if we look back at that same expression, to be like terms, they have to have exactly the same variables raised to the same powers. So when I look back at my example here, this one has an x, that one has a y, so it's different. This one doesn't have a variable, so it's different. So I have 4x and 8x would be like terms. But then I also have my two constant values. So this would be a like term to this one. So there are two pairs of like terms in that expression. These other ones we've talked about. A coefficient. The coefficient is this number that we are multiplying by our variable. So in the expression negative 4x, negative 4 would be our coefficient. I also use the term constant. A constant is a term that doesn't have a variable in it. So for instance, in the expression 5m plus 7, the constant value would be 7. The coefficient would be the 5. And the variable would be the m. So we also have variable, and a variable is the letter piece that is used in place of a number. All right, we have like terms. So if we look at an example such as this one, if I want to identify my like terms, basically I can group them together. And if I take the operation that's in front of it, then I'm allowed to do what's called combining like terms. So I can take 2x plus 6x plus 8x, and all together that gives me 16x. And if I do 5 plus 3, that makes 8. So I would have 16x plus 8. So let's try a few of these. First I have to decide, do I have like terms? And if I do, I add the coefficients, but I don't change the variable. So 6x plus 3x would make, that's right, 9x. 4a plus 2a, if I think of these as actually an object, like 4 apples plus 2 apples, that gives me a total of 6 of them, so 6a. If I have 5m plus m, we have to think for a minute, how many m's do I have here? I have 1, and if it helps you, you can write the 1 in front of it. So 5m plus 1m makes 6m. And my last one, 6x plus 8y. These aren't like terms. This one has an x and this one has a y, so it just stays 6x plus 8y. It doesn't change. We can't combine them because they're not like terms. So this one just stays 6x plus 8y. So we just rewrite it the way that it was to start. On these next ones, the only difference is, instead of adding my coefficients, I'm going to subtract them. So I have 12a minus 8a. I subtract my coefficients, so that would leave me 4a. 9b minus 4b, 9 bananas minus 4 bananas, leaves me 5 bananas, or 5b. I have 11c minus a c. So again, we have to think, okay, I have 1, so 11 minus 1 makes 10c. And 4d squared minus 2d. On this one, I have a d to the second power and a d. So even though they have the same letter, they don't have the same powers, which means those are not like terms. So I can't put those together, so my answer is simplified. I don't have to do anything to that one. I just rewrite it. Now what we're going to do, since we've taken a look at these, you're going to go on to Angel, or you're going to go back to the Angel folder, and you're going to try some of the sample questions that are in there. Take a look at the distributive property and how it works. Basically, when I have this number out in front, I have 4, and then I have an expression inside my parentheses. What this means is I have 4 sets of 2c plus 3. And when we simplify it, what we want to know is how many c's we have all together and how many 3's we have together. So if I have 4 sets of 2c, there's 1 set, 2 sets, 3 sets, 4 sets, and I also have 4 sets of 3. And that number out in front just tells me how many of them I have. And if I look at what we just talked about with combining like terms, if I have 2c plus 2c plus 2c plus 2c, that makes 8c. And 3, 6, 9, 12. So I have 8c plus 12. I can't combine those because they're not like terms. So if we look at a few more of these, I have 4, and then I have c plus 1. So basically I have 4 sets of c, and the shortcut I can use is I can multiply that number out in front times each one of the 2 pieces inside. So 4 times c gives me 4c, and I take the 4 and I multiply it by the other piece, so I have 4 times 3, which makes 12. And again, I have one term with a c, and the other term that's just a constant, so I can't add them together. Let's try the second one. So I have 3, 2c's plus 5. So 3 times 2c, I multiply those together, and that gives me 6c. And then I multiply the number out in front, the 3, times my other term, times my constant term, and that gives me plus 15. All right, if I look at this last one, 2 times 3c, again makes 6c. And then I go and I take the 2 times the 4, which makes 8. I can't combine them because I don't have like terms. So the distributive property is just a shortcut. I multiply the number out in front times each one of my terms inside. And it doesn't matter how many I have. So I have 4 times 2a, which makes 8a, and 4 times 3, which makes 12. So let's try just a couple more. So 2 times x makes 2x, and 2 times 5 makes 10. Sometimes it's helpful to make what looks kind of like a rainbow out there, and we show that we're multiplying each piece by the number out in front. So here I have 4 times 3x, which makes 12x, and 4 times 7, which makes 28. And I attach them together with the addition sign because everything there was positive. And it doesn't make any difference if I have a subtraction or if I have an addition in there. I use the same thing for each one. Alright, so if I have subtraction, it doesn't matter. I do 8 times k and 8 minus 4. So 8 times k makes 8k, and 8 times a negative 4, or minus 4, makes a minus 32. So if I put a subtraction in, it doesn't change it. I do the same thing. So 3 times 4x makes 12x, and 3 times a negative 5, 3 times minus 5, I put the minus in there, and I have a 15. Right, 7 times 6x, 7 times 6 is 42, and I keep the x on the end. And then I go back, and I do 7 times the negative 11, which makes a negative 77. And this one, 4 times 2x makes, that's right, 8x. And 4 times negative 9 makes a minus 36. Doesn't make any difference if we put some fractions in there. We know how to use fractions. Fractions are our friends. So, and when I do a half, I always just think of half of the number. So half times 8x, half of 8 makes 4. So that would make 4x. And half times negative 16 would be a minus 8. And over here, 3/4 of x makes 3x, and 3/4 of negative 8, 1/4 would be 2, so 3/4 would be 6.